Welcome to Flora and Friends, your botanical cup of tea, a podcast for plant lovers of any kind. We welcome guests to our botanical tea break to explore the history, science and meaning of plants for our lives. My name is Judith Lundberg-Felten. I'm a plant scientist, university researcher and founder of Flora-L Design, and I'm the hostess of your botanical cup of tea. Welcome to the mini-series of the Flora and Friends podcast on Pelargoniums. I'm dedicating today's episode to diverse aspects of industrial Pelargonium breeding. My interview guest today is Lennart Johnsen from Syngenta Flowers, and Lennart has worked for more than 40 years with ornamental plants and their production, partially in an own company and then in different larger companies. And Pelargonium has always been a part of the work that he has had. And today he is technical lead at Syngenta Flowers, taking care of plant testing and production, following Syngenta's breeding program of ornamental plants. And Syngenta's Flowers provides about 20% of the European Pelargonium market with plants and 30% of the Swedish Pelargonium market. I interviewed Lennart while he was on a travel to Portugal to one of Syngenta's Pelargonium facilities, and I think this interview gives lots of insights into the perspective of the ornamental plant industry, and I hope it will broaden your view on Pelargoniums even more. I would also like to apologize for the slightly suboptimal sound of this interview, but I hope that you will anyways enjoy listening to it. Welcome, Lennart.
Thank you very much. And I'm happy to be with you also and to share my knowledge with Pelargoniums.
Yes, and that brings us actually already to the first question. You're working at Syngenta with Pelargoniums, but how have Pelargoniums found their way into Syngenta? And since when have you been working with Pelargoniums in the company?
Really found a way into Syngenta. I think, they started sometime around about for 20 years ago. But really serious within Syngenta, I would say, is together with the acquisition of a German company called Fischer Pelargonium that was very specialized on Pelargoniums. And that's where actually the big step for Syngenta into the Pelargonium market came. Mm. And that is for 13 years ago.
And the production of your plants is going on in which countries?
Our production is mainly focused on 3 countries, and that is Kenya, Ethiopia for the European market, and in Mexico.
And how can we imagine the production there? Is this done in greenhouses? Is it done outside?
You have to do it in greenhouses with controlled climate and also to make sure that you have it insect free. Mm-hmm. So there is, I would say, for Pelargoniums, there is 2 bacteria that are very dangerous for Pelargoniums. One of them, the Xanthomonas, is dangerous for Pelargoniums and can kill them 100% if you don't watch out for that. But there is another bacteria that is also what we call a quarantine disease. Bacteria doesn't only affect the Pelargoniums but also affect others. So everything has to be under high hygienic conditions that you have full control on, and disinfections and all these kinds of things to make sure. And we have also for export to certain countries is controlled on a yearly basis to make sure that you have the right controls for it.
When you say now there's a serious issue with these 2 types of bacteria, What is the breeding of your plants actually aiming for? Is it to find higher resistance of pelargoniums to the bacteria, or is it more for like ornamental properties or other kind of traits that you are breeding for?
Resistance, yes, it's one of them, but I still say resistance for bacteria is a little bit more difficult to breed in. But it's one of the things, and then you can say there are other things. There is resistance for pests. It's more difficult target, but the main target is actually to say, okay, consumer value and reduction of resources to produce the plant. What I think is nice to see is that we have a switch from being what we call grower focused, which is then our customer. That's the growers that buys our cuttings, to be consumer focused, because in the end, they also buy our cuttings, but not directly from us. But in the end, we have to make sure that they like what we are doing and that they get some positive things out of the plants that we are producing. So I think from breeding point of view, there is a clear change of the target group, that's for sure.
Is the production efficiency, when you talk about that, is that related to how well you can take cuttings from the plants, or what kind of other traits are dominating the production efficiency?
Yeah, it's like you say, it's about how many cuttings the mother stock produces per week. So I mean, normally we can say a big plant that is 6, 7, 8 months old is about 2 cuttings per week. Of course, if you can increase that to 2.5, of course, that's a 25% increase. But I think in the breeding, the main target has been to say, okay, at our growers in Europe, or that is growing in countries where you are heating and the space is more expensive, it's about how many plants can they produce on the square meter.
And in terms of consumer value, what's the consumer looking for?
A lot of flowers, colors, and also that the plants continue to grow when they put them in the garden.
So when you start this breeding process, now you have these different criteria that you want to breed for. How do you choose the parental plants, and are these Pelargonium species, or have they already been improved in a way? And how do you go about when you start this process in the selection of the plants that you start with, but also how do you screen them once you get something out of this? Do you have any kind of molecular method that you're using there today?
Less than 10 years ago, we, Syngenta, actually Fisher introduced what we call interspecific pelargoniums. So that means that there is crossings of several species. And this interspecific, they are crossings of 3 different pelargonium species. And that is then wild species that is then bred into this. And with the target to have heat resistant, dross resistant, and also a plant that is giving high consumer value, meaning a lot of flowers and bright colors. This breeding was done. Syngenta, we have 2 breeding locations. We have one in the Netherlands and we have one in California. So this breeding of this interspecific was done in the Californian breeding location with the 3 wild species into one, so to say.
How do you do that with 3? Do you cross first 2 of them and then you cross the third one into this one?
Yeah.
And does it matter in which order you do it?
I think it might matter in which order you do it, but on the other hand, I would say because I say you have a lot of experimental breeding also. I mean, you have targeted breeding where we say we talk with the breeder. We have, for instance, today a variety in the assortment that is not performing very well. it is growing in this way, have red color, but we need a replacement. So I mean that is targeted breeding. Then the breeder knows more or less what he needs to cross to be able to go in that direction. But then they have also 25% of the time they use for experimental breeding. And I think like this interspecific is something coming out from the experimental breeding, where you say you do something and you don't really know what you're going to get out, but you see what's coming.
And for this kind of experimental breeding, you are always using annual herbaceous pelargoniums, or are they different? They have different growth forms, the pelargoniums. Are you using different of them, or is it always annual and herbaceous ones?
No, it's, I mean, the basis for breeding, we have what we call the Pelargonium Museum. So you see where it has been collected the wild species of Pelargoniums, and where we have, I think, close to all the different species of Pelargoniums that are around on the globe. And this is very much used for that type of breeding.
So you have a collection of all these original species growing somewhere?
Yeah. Yes, we have that in the Netherlands.
That is an interesting resource, I think, to conserve, because you are also conserving these plants and their genes by having this collection. Whereas if there's any kind of changes in with climate and or anthropogenic activities in the places where these came from originally, you still have a backup of them.
Yep, they are safe for the future.
Yeah.
And it's also because I mean that's how you can create some new funny things, so to say, by doing this with using the species from the original ones to cross them into. You can get some good things out of that. Of course, in the breeding you do it through seeds. And when you get a lot of different types, of course, the selection is the difficult part, actually, how to select the candidates that go forward. We have a system from the first, so to say, outcome of a crossing. They have 5 steps where they do selection to say, okay, when they pass to the 5th step, they feel comfortable that this is something that can be worth to look into to the market. When they're on in the last step within breeding, it's handed over to supply chain. So, and that's actually where I have the most details, because that's where I come in my area. We get then, let's say, 100 candidates from breeding that they have went through the breeding process and the different stage gates. We put this one into our first commercial production trials, which then is meaning small volume at our mother stock locations in Africa or Mexico, and where we then produce the unrooted cuttings, and this was then sent to our rooting locations where we root the cuttings then to be delivered to customers, which then is in the Netherlands or in US. And then these varieties, the 100, they go through this process, and they are also tested. We have in Europe, we have 6 test locations where we test all the varieties, to say, for the grower testing, and in the end also consumer testing. And normally out of those 100 coming out from breeding, I'll say maybe 25 goes further, to say that we say they passed the first commercial production test and the commercial consumer testing.
How long time does that take?
That takes at least, from the first step to the last, it takes at least 3 years.
Okay, Yeah.
And you can say from the breeding, having the first outcome until we say we can sell it commercially, 6-7 years.
How do you assess whether this is going to be a popular pelargonium with the consumers? Are there trends or other factors how you can predict what is going to be selling well?
I mean, you have trends, but then we also do close cooperation with retailers to have the input from what they think the consumers want, even though they are one step closer to the consumer than we are. And then we have also some consumer panels where we do then measurements on these things. And this is not only pelargoniums, because we are breeding in many other things also. And you have one pelargonium, for instance, that is also popular in Sweden, is the Swedish Pelargonium, which is a Syngenta interspecific. So that was one of the first ones we came with that has then 3 species bred into it.
Mm. I've also been reading that sometimes when you cross the plants, then you take cuttings, and then you need to take cuttings for several rounds, I guess, to see that it's stable what you have made. But sometimes during the process of making cuttings, there can occur spontaneous mutations.
You have, let's say, bee-colored varieties. You always have to do a selection. So I mean, every year we are exchanging the mother stock in our production locations. So I mean, and we have then what we call the elite material to supply to our production locations is in a site or a company that we have here in Portugal, that we have the elite material. And that is a small number of plants. And these ones, they are selected every year to what we call true to type. Because you have, even though pelargoniums goes pretty slower, but you have always a genetical drift. So if you do this true to type selection, you will say in a certain time period, the variety will change and look different.
So
and especially, like I said, with bee-colored varieties, it's much important because they drift much quicker. And as you said, sometimes you have a spontaneous mutation where you can say, but normally when that happens, you can recognize it back to one of the parents.
So it's not so easy to actually keep this once you have a very popular, let's say, popular hybrid. It's not easy to keep that stable over years.
No, I mean, you still need to maintain the genetics. Even though I say Pelargoniums is very stable, but still you have a drift. We have other things that goes much quicker.
That's really interesting in a way also that we have very popular pelargoniums here in Sweden. And it's the question if they are really still the same than more than 100 years ago when people first started to culture them. The Mårbacka pelargonium, for example, as people take cuttings and multiply them, they probably end up being something different today than what they were back in the days. How about the resistance of the pelargonium and your breeding programs, the resistance to this bacteria? Has anything been, have you made any major advancements in that sense with the breeding program?
So the resistance for the bacteria is difficult because it's connected a bit to the color of the plant also. But what we are spending resistance more is actually to what we call the post-harvest tolerance. Pelargoniums, when they are under stress, so that means when they leave the greenhouse and they go into a truck and be transported and go to the store, they start to produce gas ethylene, which we have been then identifying the genes that are, and we also know which parents we can use that has the best resistance against that. I mean, unfortunately, we are not as far with the bacteria because still I say if we could solve the bacteria problem, then we would not need to change mother stock every year, because now we change the mother stock every year, which is very costly, and also reducing the production they can give. So the older they get, I mean, to a certain extent, the more they can produce, which could be interesting. But we cannot do that because of we need to keep them clean from these bacteria. So that's why we change every year. So there we didn't succeed too much, but as I said, with other things like this ethylene tolerance, we have been succeeding better.
Yeah, that's interesting. Plant hormones are always a very interesting part of these responses.
Yeah.
I have been working on ethylene myself, so I know a little bit the story
Okay,
behind that.
yeah. Then you know, and we are working hard because in the end, you can say the ethylene does actually, we calculate that about 15% of all pelargoniums that goes into retail, they are wasted because they are not keeping the quality during the time, and often it is because of this ethylene. And I say if we could solve that problem, that would save a lot of resources, I mean, and save a lot of money for the retail. So that's why this has a focus actually, and also for the resource use, because why should we produce waste? I mean, that makes no sense.
No. How far has work on pelargoniums gone in terms of like genetically modified plants, where I mean, the breeding is one process, but you need to have like strong parents, for example, that have a good trait so that you can introduce that into subsequent generations. But if you do genetic modification, you could be targeting a very specific set of genes in the plant. Is it possible to make genetically modified pelargoniums?
Say we know the technique and we know which genes we could use, but on the other hand, it's not allowed to market gene modified ornamental plants.
Yeah, so there we are.
So that's why the breeding is traditional breeding, and I think maybe that is also the safest. I don't know what is, but this is what you say. If you could do gene modification, I mean, then you know you can target and you can exactly switch what you want. But we are the breeding is fully on the natural way.
Yeah, it's the regulations are often the most decisive point in that, whereas you could. In a way, it has always two sides. If you say 15% of the pelargoniums, they go to waste, and if that could be solved by genetically modified plant, that would also save resources.
There is always two sides of the coin.
Yeah,
that's for
exactly.
sure. And what is right and wrong, that's difficult to know.
It's difficult to say. Even the breeding has also the downside that we don't always look at all the different traits that have been changed. So there's much more regulations for the GM plants as for bred plants, for example. So even there's two sides of the coin. But I was wondering if when it comes to the infection, have you been trying, for example, to keep these plants in sterile culture systems where they would not be sensitive to this bacteria? Or are these bacteria living inside the plant tissues already and they get active under these stress conditions?
I mean, yes, the bacteria can be latent in the plant, and when you get certain conditions, it dominates the plants. But I say for our production, we have different steps. So I say that the first step is actually it's what we say. We start with a medicine in vitro culture, which is then 100% tested. These plants are then grown in a very, I mean, it's not sterile, because it's a greenhouse, but it's very strict conditions and everything, and that is a special greenhouse, and it's on a location that we have in Portugal. So here we then do all what we call the super elite. So these ones then are supplying all the starting material towards our production farms.
Mm.
And I mean, here strict hygiene conditions, and the plants are standing with wide distance, not touching each other. You have no water splashing and all these kind of things, just to keep. And you have double entrances. Everyone has clothes and disinfection between the plants, and all these steps that you can take to secure yourself.
Mm.
But then it goes down to the production farms where you cannot work in that way, because I mean it would be way too costly. So of course there you have less phytosanitary regulations and levels, but because you have also to look a bit to the efficiency. But still, I would say, looking to a normal greenhouse production, there are still high hygienic conditions, because you have double entries, the disinfection entering, special protection clothes, disinfection units, and all these kind of things to keep the contaminations away. And I mean, the Santa Monas, which then is the specific for pelargoniums, doesn't have very many host plants. So I mean, there you can say, if you keep strict conditions you have on the material you're getting in and on the production, you are pretty safe. But then you have the other one, the Alstonia, which has other host plants, which then it's more tricky, and it can also be spread through the water, irrigation water. So for instance, our irrigation water in Africa is disinfected 2 times by UV and also by ozone. So I mean, we are disinfecting it 2 times to be sure that we don't get it through the irrigation water.
Mm. Is there any kind of research done on like biocontrol, for example? Are there other species that are repelling this bacteria, or any kind of other organisms that would help the plant to be stronger to resist them?
Yes, and there have been, so I say, chemicals that was allowed for quite some years ago that you could use when if you got an infection, just to cure it and to suppress the infection. But I mean, as we are going to a more sustainable globe, I mean, the use of chemicals and other artificial things to keep them from getting a disease and less, and we need to more rely on other means to do it.
Mm. There's no like beneficial microorganisms interacting with the pelargoniums that could be used to make the plant stronger?
Not known. Not known.
And do you know these bacteria, are they also infecting the plants so often when the plants are in their natural context?
No, I think you see it more when you do it in a crowded context, so to say, a commercial production where you have many individuals collected together, maybe a little bit like people. On the countryside, they are less sick than they are in the town, in the city. Yeah.
Yeah, that's indeed. I was wondering, because sometimes looking into like all plants have a microbiome, as we humans have as well, and identifying plants that have a very good resistance. Sometimes it's due to their genes, but sometimes it can be due to any kind of like microorganisms interacting with them and making them more resistant. So, but if it's a problem of like the plants being very much crowded and then they get more susceptible, that's of course not a condition that one has in nature as such. Yes. One question. So if people want to find out more about Syngenta flowers, or finding more about where they could get the interspecific pelargonium?
I say the only retailer I know that is really marketing them as interspecific is Plantasjen actually. But I say the other ones, Blomsterlandet, they have them also. I mean, and it's Kärleks pelargon. I mean, that is the main one within this series, the red one. So I mean, we do together with Plantasjen and the growers they have. So they have a program with interspecific pelargoniums in different colors. Bigger pot than normally, and has a bit more bigger plants on it. So this program they launched, was it 3 years ago, I think, actually, something like that. With actually we pushing them, because when we approached Plantasjen, they said, yeah, but we cannot sell them for the price that we would like to do, because this has to be more expensive, because the production price is more expensive. So I said, and then we don't believe we will be able to sell any volumes. But we insisted and we helped them with marketing the first years to launch this program with interspecific pelargoniums. And I mean, since then it has been running and they are very happy with the outcome. And every year the volumes is increasing. But of course, I think, I don't remember the pricing, if they take 49 for these ones, and a normal pelargonium costs around 25, I think, in Sweden now. And it's almost the double of the price. And then as a consumer, you stand there, you say, okay, am I going to buy 2 or 1? But shows, and we have done some market research also together with Plantasjen and another retailer in Germany where we have also launched. And it shows that the people that bought it the first year, they will buy it the second and the third year also, because they had much more happiness with the plant in the garden or on the balcony.
I'm always in favor for putting down some more crowns or euros or whatever onto good quality plants. It's usually making one happier in the long run as well, when they are nice and they are growing nicely and they are thriving.
And what they should remember, I mean, the pelargoniums that you have for the 25 crowns price in retail, I mean, it's the very compact varieties. They just to be possible to produce them very densely with many plants on a square meter. So it's compact growing varieties. And I mean, when you put those ones in the garden or you put them on the balcony, they will have difficulty to continue to growing up. But if you go to the more expensive ones where you are not able to produce so many per square meter, because they are strongly growing and they need the space. Of course, yes, a bit more expensive, but they will start growing when you plant them in the garden or you plant them on your balcony. I mean, then they will continue to grow.
Do you have pelargoniums in your own garden or balcony or on your windowsill?
That question I don't like. No, some yes, but you normally say the worst garden is the ones that are working with it on a daily basis. So they normally say the children with the worst shoes are the ones from the shoemaker. So
yeah, that's also reasoning. I think I've been sharing always stories how my plants die, so I'm soon not going to be a believable plant biologist anymore. Thank you very much. I think that was a lot of very interesting insights into the industrial perspective of pelargonium breeding, and also the challenges that you are facing today, and something that we as a consumer in the end that buy the plant often don't think about. It's like already thinking where this plant came from and what was involved in all that process until it arrived in our store.
Yep, and I think actually always when I start to think, I see a pelargonium in the store, and then I think backwards in the chain to see what steps, what really needed to be done to bring this pelargonium here in the store. And then I say it's sometimes you get amazed with the chain when you start from breeding until the plant is standing in the store. And then you say, and it only costs 25 crowns.
This is also, I think, something for the consumer to have in mind, that it's the number of steps, but also the time that it took to make this plant that in the end is standing on our windowsill, and the amount of people who worked with this as well until this is ready. Thank you very much.
You are welcome.
I hope you have enjoyed this episode. And if you haven't listened to our other episodes about pelargoniums yet, where we discuss their history, their medical use, biotechnology, and how you can easily grow them yourself, then visit our webpage at www.flora-l.com/blog, where you can find all Flora and Friends podcast episodes. To keep yourself up to date on new releases of episodes, I invite you to sign up for the Flora-L newsletter while you are on our webpage. I hope you will be back next Wednesday for the next Flora and Friends episode, where we dedicate our discussion and interview to the Pelargonium genus and its ecology. We're going to visit in our interview several places where pelargoniums are naturally grown. So a nice little tour through their original habitats and how they thrive there, but also what their challenges are there today. Thank you for listening and have a nice day.